Okay, so Niels, can you introduce yourself, please?
Yes, hello everyone. I'm Niels Bakker. I work with Noviqtech. Previously, we've been known as Timeless. We recently had a name change, hence the different company name. I'm a blockchain engineer and consultant, and I work on the Truth project, which is what you shortly introduced before. Shall I tell something about that as well, or
Let's wait that for later. Yeah.
Okay.
Good morning, wherever you are, everybody. Andrea, co-founder of Forkbomb BV. We work primarily with cryptography and everything that goes around it. So blockchain interoperability, digital identity, and we have a couple of projects going in the energy sector.
Okay. Thank you. So I want to start off with just one question, and that's if you reflect a little bit on programmable energy, what's your view? Does it have legs? Is there something in it, or is it not worthwhile to endeavor? Yeah, Andrea?
Well, there are many good reasons to look at programmable energy. We are transitioning from a phase where until a few years ago, in most countries in Europe or in many countries in Europe, all the production of energy was done by a monopolist, typically a state-owned company. We transitioned to a level where people could start producing their own energy, but sell it back to the monopolist and then buy back. And now basically everybody can produce energy, which opens scenarios that were not possible because of regulations a few years ago. And at the same time, we have different technologies that came up in the last couple of decades. So first the internet, then the widespread use of smartphones, which are not called smartphones anymore, they're just called phones. And lately also blockchain, which helps to make data provenance sure. So we have a mix of change in regulation, change in technology, which opens up a bunch of different possibilities.
Right. Okay, thank you. And Niels? So on programmable energy, is it something that we need everyone to support and work on it and find the right way to harness it, or?
I think it's a hard question. I think programmable energy really came about when the grid had to change, when our energy grid went from centralized to now slightly more decentralized, and it will even get more decentralized. And I think that's mainly because of the renewable energies that we have now. They're in a much more decentralized way. You can install them on your roof, you can install them in your garden, doesn't matter. And I think even if you cannot participate with the investment of solar panels or anything else, programmable energy can make everyone a part of the grid, where we can create a truly decentralized energy grid, which will be very important in the future.
So, and what aspect of programmable energy is very appealing to you?
I think it's very interesting to. What appeals me the most is that obviously the whole energy grid. It's much like the water works within a city. It flows, and it flows in a direction you don't know. From the water pump, I cannot tell which water droplet goes out in what faucet in what house, and that's the same with the energy grid. So it gets produced with whom uses it. And everything we do is basically a representation of what happened in the best possible way, but it's never perfect. And I like that because you can come close to perfection. You can maybe in the future have your solar panels on your roof and charge your electric car a few cities away with your own energy. But you can never get a 100% representation, and that's what I like most about programmable energy.
Okay. So, and Andrea, what's your most what aspect do you most like about programmable energy?
The fact that it's about decentralization in many different ways, under different aspects. So in the past, energy production was mostly done by very large, very expensive infrastructure, and also because of that, it made financially more sense that countries were building and running this infrastructure and then distributing the energy among the citizens. In the past 2-3 decades, we had a very dense development, very strong development of new energy production technologies, renewables in in different ways. So wind power, solar power, which require a much smaller investment and can be placed more or less everywhere. Energy programmability gives the chance to split even further or to make even smaller the token to get into investment to build and run this kind of infrastructure. So that gives the chance to basically anybody to buy 1% of a windmill and to profit from 1% of the mill production, whether in a financial way or by using the energy themselves. This industry, this vertical is in its infancy, but the fact that it's going to be possible for regular people with no investment background to take part in investment of this kind of infrastructure will probably create all sort of side collateral markets, and it will just add up to the economy while helping to solve the energy issue, which is we all know what happened since last year with the war in Ukraine. Everybody suddenly woke up and realized that Europe, without the help of Russia, cannot run. This is obviously it is an issue in the present and in the medium run. In the long run, it should be solved with the help of other ways of producing energy that can be more decentralized.
Yeah. So, and when you reflect then on the role of programmable energy in that changing landscape, what are you missing in the programmable energy concept as it's being articulated today?
So, this needs to be looked at from different lenses. There is a regulatory part, which is still it's in its infancy. Every European country have its own regulation. We were just discussing before about the differences of small energy producers in the Netherlands and in Germany. In the Netherlands, they need to pay VAT. In Germany, sometimes they don't. And that adds a 21-22%, or in Denmark, 25% difference. So the regulation should be harmonized and should keep in account this new industrial scenario where it's not a country building a huge power plant, but it's a small community that can be as small as a building their own small power production facility. On the other hand, we have barriers because of the infrastructure itself. First, because not all the cables are born equal, and not all the infrastructure connecting the cables are born equal. So if I want to move electricity from Italy to Germany and then to a different country, the electricity needs to be converted and transformed in different ways. Third, because as of today, transporting electricity is like having a water pipe where every 10 meters a little drop falls. And there are efforts being made on superconductive or more conductive electricity cables, which is something that again, it's a bunch of new technologies, new legal frameworks pushing each other. I watched recently a TV program talking about the dream of electricity being produced by a solar panel in Sicily and powering a EV car in Denmark. This is challenging today because if you try to move electricity for 3,000 kilometers, a lot of it will be lost on the way. Electricity needs to be transformed over and over again. Plus, electricity needs to travel through 3-4 countries. All of that needs to be reshaped and to be enhanced in order to make programmable energy part of everybody's everyday life in Europe.
Okay. So and Niels, so if you reflect on your MOI project, right? So what are you missing in the programmable energy to apply it in your project?
I think I think regulations is one of the biggest points, and mainly the resulting business case out of the existing regulations. So, for example, let's say I install solar panels right on top of my roof. It's behind my smart meter, and then you can with the current regulations, the solderingsregeling, you get basically your tax back for every kilowatt hour you sell back to your energy supplier. So it boils down to, if you pay 20 cents per kilowatt hour, if you produce a certain amount of kilowatt hours, you get 20 cents for those kilowatt hours back, which makes sense, and it results in a great business case. If you want solar panels and you have your own roof, do it. But let's say I can't, and I want to have solar panels somewhere else. And I put my solar panels there, and I put a meter there, and then I want to use my own solar energy. And then I only get paid for the actual energy price, which is like only 10, maybe 20% of the total amount, the total sum. So will we implement something which facilitates that? Not really, because it's not really a valid business case right now to do that. I think that's a big point.
Okay, yeah. So, but that's more, I think, the Dutch regulation currently with local netting that we do. Okay. So, and if you then see some potential in the concept, what's then the next step that you think the Two Tokens Foundation need to do to support this whole initiative?
Well, I think the sessions such we have today, it's really good because we sit down with a couple of working groups with actual cases, and they present their problem, and we come up with a way how this could be technically implemented, and that can be presented to lawmakers, to municipalities or government bodies, which can then say, okay, let's do a pilot. And then when you do one pilot, 10 pilots, 20 pilots throughout the whole country, then they maybe say, okay, let's agree that when you are within a community, you can, for example, exchange energy without VAT or something like that. So I think it's important to first sketch the possibilities, and then to pilot these within the
current regulatory framework, or
I think that's part of it,
okay.
But also the technical implementation is important, because it all sounds good when you think of it, and then you implement it, and then maybe the technically the net beheerder, the district operator, they will say, oh no, but that won't work because the energy has to transfer from here to here. And I think with a pilot, it can all come together where you work out what you thought of, and technically you have to implement it, so you prove it's possible, and then they can see whether they have to change certain laws or other things to facilitate this.
Okay, cool. And then from your perspective, Andrea, what do you think the Two Tokens Foundation can do as a next step on the domain of programmable energy?
I think that since this is an industry and application in its infancy, what could accelerate the process is bringing all the stakeholders at the table regularly. The stakeholders here are the people that want to use the electricity that cannot join one-to-one to the table, so they have to gather themselves in sort of communities. The regulators and the political entities, be it local or national. The technology actors, both on the hardware as in infrastructure part, larger infrastructure, so people building transport infrastructure, as well as smaller infrastructure such as controllers and smaller IoT devices, software developers as well, and the various operators offering a service, so the people that buy the infrastructure and lend it out as a service. They all should be sitting together because obviously they all have different, sometimes conflicting interests. And if you don't sit down and find an agreement about how to proceed, until that happens, until an agreement is found directly or indirectly, then the market cannot.
Okay. Yeah. So and what about the multimodality? Yeah? So we are now focusing on electricity, but energy can also encompass heat and cold, gas. Yeah. So is that an integral part in your way of thinking and your projects that you work on, or is it quite different domains yet?
I think that okay, that is a good question, because so far we've been focusing on renewable electricity from wind and solar. But and the reason is that the main reason is that the financial barrier to entering an investment like this is relatively small, because a solar panel can be afforded by many people. There are smaller and smaller windmills that also become more and more affordable. While coal is traditionally a very finance and equipment heavy industry, because whether you need to dig coal or you need to make a big hole in the ground, throw some wood in it and wait. Historically gas have been mostly mined, even though there is a growing trend of renewable / green gas coming from recycled urban wastes. But as far as I understand, the investment to build a plant to recycle urban waste into gas is still an order of magnitude bigger than 1 or 2 orders of magnitude bigger than building a solar panel. Okay. Therefore, to my knowledge, there has not been a major focus on this kind of energy production type and technologies. It has been mostly with the solar and wind produce electricity.
So and Niels, so when we shift a little bit to the technology landscape, right? So are there any trends, any developments that you see? Well, we started off quite some years back with Ethereum and with perhaps permission blockchains like Hyperledger? And what do you see in these developments that might be relevant for our industry?
I think one of the good things that's happening right now is that mostly when you look at Ethereum as well, which made that switch, it's the consensus protocol that the blockchains use. Because if you use a proof of work, for example, it uses a lot of energy, and to prove or to create kilowatt-hour tokens on a blockchain which uses more kilowatt-hour per token than actually in the token itself, it doesn't really make sense at all. So I think it's very good that there's a certain kind of awareness around the energy use of the blockchain itself. And you see more and more chains or hash graphs or things you see coming up with lower and lower energy consumption, and I think that's a very important one as well. The other aspect can be the speed of the chains, right? Because if you for example, right now your meters at home will send a measurement every 15 minutes to the metering company. If I want to do that for an entire city, it's 15 measurements per household, all coming together. So that's a lot. And if you all want to tokenize that and put that on a chain, for example, you need to have a big speed, big transactions per second to be allowed to pass through that network. And I think that's one thing that has improved massively as well. Okay. So that's very important.
So good to hear, because in the Netherlands and I think most countries in Europe, we do meter read collections once a day.
Yeah.
Although the meter values are per 15 minutes. Based on a new directive from the EU, I see that the proposed new energy law in the Netherlands is to collect it indeed in real time.
Yeah.
So we're gonna collect 15 minutes within a reasonable time frame after that. Yeah. So within the next 15 minutes. So we have more visibility on congestion and also on balancing. You know, so the balance service providers need to have more granular data on a more real-time basis. Yeah. So, but then, Andrea, so one of the things that is very much in the news is distributed autonomous organizations. You know? So what's your view on how that fits with energy cooperative, energy collectives, programmable energies, and the blockchains and the tokens that we were discussing today?
Yes, so distributed autonomous organizations, or DAOs, are ways to have, let me rephrase, they are a blockchain equivalent of communities who vote to take decisions. Yes, so they offer a digital and blockchain-based way to have a governance. So within the energy programmability, for a number of reasons, there is a more or less stable consensus on using blockchain to measure several different kind of values. First of all, the energy product output and so output and consumption. Around the production, typically communities are deciding how to invest in infrastructure and how to use this infrastructure. And governance of making those kind of decisions is it always requires a lot of work. You need to explain people, then you need to collect their votes. A DAO can help in the sense that using the same technological infrastructure and the same, meaning the same blockchain, you can record the energy being produced or being used. You can record a financial counterpart to energy use and energy consumption. And at the same time, you can record who voted to install that solar panel there, or instead who didn't vote to install that windmill there. And everything can be recorded together,
right?
Which helps transparency, and it makes the whole governance easier to manage.
Okay. And you, Niels? on DAOs and energy?
I must admit, and maybe I've not seen the news that much then lately. I don't know that much about the new initiatives. But
No, that's okay. That's okay. Then let me then come to a closure, right? So Niels, what kind of question do you want to ask Andrea? Yeah.
Well, I guess what's really interesting is with the landscape always shifts from centralized to decentralized. If you look back, do you think that ever we will have a truly centralized electricity grid again?
I guess that everything is going towards decentralization. So I would say not within the next 50 years.
So and then a follow-up question, if I may. Yeah.
Yeah,
So
sure.
we see a lot of large investments in large wind farms offshore. Yeah. So is that then, in your view, a decentral solution or a central solution?
It depends on who owns it and the governance. Because if it's one entity owning it, then it's
Shell.
more centralized.
Yeah, Shell, for instance.
But
yeah.
if they start, if they ask people to invest €100 each to buy 0.1% of the farm, then it's more decentralized.
Yeah. That's not on the table, as far as I know. But okay. You have a follow-on question, Niels, or?
No.
Okay. So then for you, Andrea, what question do you want to ask Niels?
Oh, I wasn't prepared for that.
really?
I would ask something more technical.
Yeah, sure.
So, how are you working with tokenization and digital? Are you connecting digital identity? So identification of the people behind the tokens with tokenization, if you're doing any work on that.
Yeah, I can explain a little bit about that. We do that. We tokenize right now the CO2 emissions that certain entities create, and we also tokenize the green energy they might export to the grid when they, for example, have solar panels and have a surplus of energy. And I say entities because we do that per meter, right? Because we get the meter data and we look how much CO2 is emitted by the electricity use. We do that by calculating the grid-specific CO2 factor. So for example, 200 grams of CO2 per kilowatt hour. And then you look at the energy usage and you can see how much CO2 is emitted. And then the question is, who owns these tokens, or who owns this emission proof of certificate? And that's because we do it with utility buildings. It will be the owner of the building owner, or the company that owns it. So we don't have that much privacy issues like for homes and stuff, where you don't want to necessarily publish this data or see it from anyone. So that's my personal working experience with the tokenization.
Thank you.
So and then a follow-up question on that for you, Andrea. So the focus, I reflect a little bit on our discussion, is more on organizations doing energy generation, shifting to decentral, always in the human in the loop. You know? So what about the machine economy, where those generating entities and your large energy consuming devices like heat pumps and EVs start to have intelligence themselves and want to autonomously participate in this whole?
They want to autonomously start producing, or they want to decide when they use it?
Yeah, so whatever. You know, what's your view on that? Is it a long way off, or do you see that emerging, or is it an appealing concept?
It's definitely a topic coming up in different ways. So we were talking about a community in the Netherlands who produces electricity. They don't wanna sell it outside the community, so they wanna keep it internal. In any case, sometimes their production covers the needs of the community. Sometimes they need to import electricity from the outside. When they import it from the outside, it's obviously more expensive. Because of this, with energy programmability, it is there is work being made on introducing a reward system for users, meaning people, who choose to use electricity only when it's cheaper, therefore not when it's not imported. How do you do this in reality? You need to have a server out there that tells you every hour or every 15 minutes, it tells you the cost of the electricity on the grid that you are attached to. And then you should be able to decide when you run, when to turn on your washing machine, your dishwasher. This is very, very cumbersome. It can be done, but it requires the person just to live in front of the phone and decide when to push that button or not. This can be helped by plugging dishwashers and washing machine to Wi-Fi powered plugs. On the other hand, like as a mirror of this, it is becoming more and more common to have large batteries at home or large industrial batteries that can have relatively wide storage. And those batteries need to understand when they can take in energy from the grid and when they can throw energy out. And they most likely will make the decision themselves based on the energy market price. So those are the two examples I can think of. And in the same fashion, it's even easier for an EV car. If the EV car gets, when it gets in the garage, the owner plugs in the recharge cable, or the recharge cable, as we saw, gets in the car by itself. We also saw that video, I guess, from Tesla. The car, since it's already connected to the internet, can decide at what time it wants to suck the energy out of the grid. Yeah.
Okay. So closing off, any last remarks, Niels, from your end?
No, not really.
No?
I enjoyed being guest here for the first time.
Well, so... And Andrea, any remarks from your end?
Yes. I would say that in Europe, we're doing a lot of things very well. We're doing some things not that well, some countries better than others. We have been dependent on third-party countries for forever, energy-wise. I'm talking mostly of the oil manufacturers, the gas manufacturers. So in Europe, we consume energy, but we don't have a lot of it. This can flip the table. And so it can, on one hand, can reduce our dependence on external geopolitical entities. In second, it can trigger a snowball effect that is technological wise, meaning that we are developing the technology we're going to use, but other countries may lack our technology, so they may start buying it, which is something similar to what happened in Norway. In Norway, at some point in the 50s, they found oil, but they started developing their own technology to extract oil. And as of today, a large chunk of the money the oil industry makes in Norway is not because of the extraction, but because of the export of technology. So that's where I hope we will find ourselves in a decade or two.
Right. Okay.
Yeah, it's going to take a while, but...
Yeah. Okay, thank you. So closing this interview, so if you have specific topics that you want to have us discussed, please let us know. If you want to have more information on energy tokenization, programmable energy, please visit our website, energytoken.eu. And thank you for listening, and until next time.
That was it for today's podcast. Thank you for listening in, and please subscribe so you don't miss out on our upcoming episodes. If you want to get in touch with us, you can find our contact details at www.twotokens.org.